Hey, Content and MAM fans. This webinar will discuss some technical options that media and entertainment companies have when migrating their archives to Amazon Web Services. Specifically, we'll talk about how to optimize this process using a serverless ingest management solution framework. I'll provide an overview of moving from on-premise tape archives to a cloud-based archiving solution. We'll talk about serverless and why it's a game changer for improving the ingest of media archives, and we'll provide a demonstration of the serverless ingest framework. All right. So hello everybody, I'm Jack Wenzinger and I'm based in Colorado. I've been working in the M&E space close to 20 years and I've just hit my first anniversary with Amazon Web Services. Time at AWS is like dog years in the sense I feel like I've gone through 7 years worth of excitement and training in the last 12 months. I'm a global M&E partner solutions architect with most of my experience around digitization strategies, media asset management, workflow optimization, and networking. I started in M&E right when the digital transformation from film started, which was fun, but the industry has never been more exciting than it is right now. The innovation that's possible in the cloud is amazing and allows us to start solving higher quality problems. So let's talk tape to cloud migration. No, I'm kidding. This webinar won't start here. However, if you have a petabyte scale content archives, you know that this is a reality and not a joke. Although, I was looking at this item on Amazon the other day and thought the fresh copy maker combination would certainly help when making freshly baked digibetas. So AWS is active in every facet of the media lifecycle, whether you measure this from glass to glass or script to screen. This diagram represents the workload categories most commonly implemented within M&E in the cloud. The decision to run your media production systems up in the cloud was pretty brave 5 years ago, but it's now a common strategy element for customers to migrate, improve, and actively manage their production in the cloud. We're going to focus on the archive migration piece, and as you can see, you'd be in pretty good company to do so. So the discussion to do archive migration is never a fun one. You'll find that management often thinks of this in the same way as speed reading the obituaries. And it's just because it doesn't, it's not commonly seen as, improving the overall business productivity or ability to increase revenue. So, the considerations are the CapEx investment, LTO robots and tape readers, and all the infrastructure involved in that is expensive and has a long depreciation schedule. You have format and metadata disparity, which is not really known by the business or what the cost impacts are, but not everything has the exact same ability to be discovered by your business and be utilized. And of course, the integration of on-site services, there's a lot of unknowns in the integration capabilities that have to be managed, which is a time and resource issue with the site to do the migration. There's unknown assets and duplicates. This goes back to the format disparity of, some assets just don't have a lot of metadata against them and you don't know what you have. It's a complex status quo project, so it takes a lot of time, resource, and calculation and logistics to manage a migration on site without, again, improving the revenue or utility of the site. You have an unknown migration capacity, which most businesses do not know, how much excess ability they have on their tape readers, so that, pulling content off the site is an unknown. And then, of course, it's just the fear of change and the cost associated with these projects. It's important to put in context the true cost of maintaining your archive on premise. You need to consider the full infrastructure cost of equipment. Some costs are quantifiable, like support and facilities. Others are not, like delays in access to content and how it impacts your business opportunities, like not being able to find your content. One thing's for sure, a friend of mine, Mark Lemons, used to quote this all the time. Not all content drives revenue, but all content drives cost. So let's talk about this archive migration in the context of moving your content to the cloud. For the purposes of this webinar, I'm going to assume that you're all familiar with the cloud and have a fair understanding of the benefits that it provides, which are listed here. If anyone would like to hear me evangelize on this topic, please feel free to reach out to me and make sure you have a couple of hours free. I will, however, go over the specific benefits to moving content into the cloud. The first key benefit is to know that Amazon provides a full suite of storage capabilities and storage tiers for managing catalogs of content in the cloud. You have S3 Standard, which is active object store, which has multiple flavors, including infrequent access and single zone for different economics. And you also have Amazon Glacier for archiving. The complexity of managing the content in the cloud is a great deal lower as well if you consider this against the ability of managing LTO generations, multiple sites, and managing the bit rot issues that happen with on-prem systems. The next key benefit, of course, is it's strictly a pay-as-you-go pricing, and pricing adjustments are common for AWS services. AWS has lowered its pricing in AWS 66 times since inception. So, you got to ask yourself, how much are you paying for unused capacity, for RAID overhead, for DR and replication? Now, while, the past performance of price reduction is no guarantee of future changes, but, based off the graph, I'd say it's pretty good, and you won't get that from CapEx equipment. Another key differentiator from an on-prem tape archive is the fact that this content in the cloud will be globally available and has 11 nines of durability. This enables your business and your customers to have access, if authorized, to the content. I think it makes the cloud an ideal location to store IMF, DCP, and master materials for quick global distribution. And I'm not aware of any on-site archive system that can offer this level of durability. I would think a key motivator for management is to never have the conversation about tech refresh again, because it's always a long, arduous conversation, and again, it's like reshingling your house or replacing the water heater in your home. It's a foundation change that doesn't obviously change the revenue line. And there's always additional cost factors because everyone's always comparing it to just the tape, but you always have to think about the facility and the staffing and the support. And then, of course, it's the generations of LTO. Are you on LTO 3 and you're trying to go to LTO 7? And do you have the right readers? This process is time intensive and expensive. So to be able to have that conversation for the very last time, I think would be a tremendous benefit. Another major benefit to moving to the cloud is the fact that a large portion of your security considerations are removed and managed for you. Amazon has the concept of a shared security model where they manage a lot of the considerations on the physical level for you. The shared security model breaks out security so that AWS is responsible for the security of the cloud. And customers are provided with tools and best practices and other information where they're responsible for security and compliance in the cloud. We have teams of people that are happy to work with you to make sure that your content is secure. And we also have additional collateral that can even run you through checklists to ensure that you're running MAM and production systems like rendering safely in the cloud. Okay, to me, this is probably the most important reason you would move to the cloud. Many of you have multiple petabyte archives on-prem, and they're probably decades old, where even you have the tape robot, but you also even have videotape sitting on the shelf. And I want to ask you, to ask yourself exactly, is all the metadata the same? Likely not. It's likely, similar to tree rings where you've had organic change over the years, where the older content may only even have a barcode associated to it, so you're not even sure what's on that content. You could probably have lots of duplication on site and other issues with the content. The benefit of migration into the cloud is you can take advantage of this serverless framework and machine learning and other services available to you in the cloud to where you would be able to process this content, to true up and create a standardized metadata footprint in the cloud against all of your assets, improving overall search and actually knowing what you have in your archive. It also gives you the ability to find the individual management solutions of content on-prem and move those into a content lake strategy in the cloud where all of that content can then be leveraged into different use cases for the business. So let's just look at one customer's at-scale cost comparison of Amazon Glacier versus on-prem. Sony New Media Solutions Group, they're responsible for distribution and supply chain management for studios, broadcasters, music labels, game companies, and other content providers. They store about 20 petabytes of data and grow at about a petabyte a quarter. As you can see here from the graph, because of that technology refresh, they'll see different costs each year, but ultimately it is a larger cost footprint than just running your content within the cloud. So let's talk the serverless ingest management solution framework. Essentially, we're trying to create some solution strategy that makes it easier to move content into the cloud, but not just move it for doing another technology refresh, but working with the content to create a baseline content and metadata structure for customers. So the first part is the on-premise challenge of helping customers overcome getting content out of their legacy LTO archives, overcoming the complexity of proprietary formats or any kind of integration issues that they have on site. And of course, Amazon has ISV partners that can support this, like CloudFirst. The second part of this is in the cloud, when you have the content there, being able to work with the content, create standardized outputs for content proxies, and develop a baseline of metadata leveraging machine learning tools to ensure that once this content is brought back online, that you have an improved search experience. And essentially creating a customer-controlled content and metadata structure in cloud storage, and then providing the customer the ability to do a MAM-focused user experience and media tools strategy. So for customers that can't afford having their day-to-day business interrupted or need additional support on site, AWS partners with companies like CloudFirst.io. They have the ability to put technology in front of your LTO archive and help you determine what excess capacity you have, address the complexities of the local format, whether you're dealing with StoreNext or Diva or any other type of LTO archive system on site. Get the content up into a state where it can be brought into Amazon S3, where an ingest process can take place. Once content is out of your archive, there are multiple paths available for bringing content into the cloud. You can use AWS Direct Connect, which we have multiple partners for. There's also Snowball, which is a hardened hard drive platform that can be delivered to site and take content from the site at 100 terabytes per appliance. We also have AWS Snowball, so if you have multiple petabyte scale and need to move content quickly, there's literally a semi that will come to your facility and help you get content offloaded into the semi. We have multiple partners for this type of capability, Signiant or Spera or acceleration transfers, or you can use the S3 transfer acceleration, or you can leverage one of our AWS storage gateways. Ultimately, you want to get to master assets with a sidecar XML for the baseline metadata that's associated to the asset, and then trigger this serverless ingest process. So let's go over what serverless is. It's probably easiest to explain serverless in the context of how cloud is evolving. So you started with physical servers and data centers and then went to virtual servers and data centers, which lowered your overall physical management aspects of the content. Then, of course, when the cloud came around, you moved your virtual servers to the cloud, which even reduced your management and facilities even further. Serverless is literally taking the server out of the whole equation, lowering your IT management expertise so that you can focus specifically on the coding aspects and managing the business aspects of your business. So essentially, it's kind of like the same evolution that happened where large corporations all had their own printing facilities on site, and then came the Kinkos and everybody outsourced it. So you no longer had to have this expertise that was not part of your core business. Serverless is much the same way. Serverless is just easier to manage. So if you think about it, provisioning and utilization goes away. The availability and fault tolerance that you're managing goes away. You don't have to worry about scaling or operations and management. It is just there when you need it. And the beauty of serverless is it delivers on demand, never pay for idle. It's an event-driven service. It continuously scales based off what you need, and you only pay for what you use. It's perfect for archive migrations because based off the amount of content that you're putting into the cloud, it's only using what you need to process that content. So essentially, the ingest strategy you establish in the cloud can be the exact same one that you establish for your production content. Finally, combining your ingest workloads into a single strategy. So just to clarify, serverless means no server management. There's no need to provision or maintain any servers. There's no software or runtime to install, maintain, or administer. It's just that core logic that actually runs your business is what you're running in the cloud. You have flexible scaling. As each request arrives, Lambda determines where to run it. Instead of provisioning for peak capacity, developers simply let Lambda handle their workloads. It's highly available. Like scaling, availability, and fault tolerant are built into Lambda, eliminating one of the primary challenges of building a robust distributed application. And there's no idle capacity. There's no need to pre or over provision capacity, and there's no charge when code is not running. Amazon has an extensive catalog of capabilities that are considered serverless, where the user does not have to manage all of the underlying infrastructure or scalability. AWS Lambda is the flagship of this, which started this whole trend, which essentially is the ability to put your code into a service that can be triggered by events, such as an asset and metadata file landing into our storage services. But essentially, database, messaging, all of these services are available in a serverless mode. The key ones that enable our serverless ingest strategy, obviously, are Lambda, the storage, but machine learning for adding additional metadata against each of the assets. And the thing that ties this all together, of course, is the AWS step functions for orchestration. AWS step functions is the orchestration layer that manages the media workflows for our ingest strategy. It lets you build visual workflows that enable quick translation of the requirements that you have into technical implementation. You can build applications in a matter of minutes, and when you need changes, you can swap or organize using the visual references that it gives you. It creates a graphical representation of the workflow that you're designing. So let's just walk through an AWS step functions example. Say I want to upload some photos, and I want to be able to make some thumbnails, I want to extract some metadata, and I also want to use Amazon recognition to be able to do some object recognition within the file. On the right side here, you're actually seeing what a step functions workflow would look like once this has been coded in just standard JSON logic. So it's a JSON-driven workflow. It essentially is event-driven off the states. So it can tie multiple Lambda functions together in a series, in a linear fashion, or in parallel, and work with all of the other serverless activities to generate this type of screen based off the JSON. So you'll get a graphical view, you'll get a debugging view, and it makes it very easy to code out the workflow that you're trying to orchestrate for your business. So I think the best way to continue this webinar is probably let's dive into the demo that we did for IBC. All right, so with that, Ken and Dan, do we have you online?
Yes, hi, Jack.
Hey,
Jack.
All right, great. Hey, Ken, you want to quickly introduce yourself?
Yes, hi, my name is Ken Shack. I'm the Media Entertainment Specialist Solution Architect.
And Dan?
Dan Sievers. I am a senior consultant with the global M&E.
Professional services, correct?
Professional services, thank you.
Awesome. All right, so with that, let's just kind of cut over to the overview, and I'm going to let Ken take it away. But essentially, the services ingest framework that we're showing here is the same one that we demonstrated at IBC 2018 a few weeks back. So you're going to see the ingest manager dashboard come up. We're going to import an asset, and we're actually going to step through the process of taking some JSON, importing a file, assigning the UUID MD5, creating the proxies, running the AI analysis tool sets to create that augmented metadata, and then Ken will show that and how it's ingested through the dashboard. So with that, Ken, you want to share your screen and take it away?
All right, sounds good. All right, can you guys see my screen?
Yeah, I can.
Okay, great. So I'm just gonna walk through the demo real quick, starting with sign in with the Cognito services.
Incognito is like a single sign-on service?
Yes, Cognito. So our Cognito service is the authentication service that also supports federated identity as well.
Oh, nice.
Yep. So let's do a sign in. All right. So once we sign in, the very first thing that I'm going to do is I'm going to upload a file to kick off the ingest workflow. So this step is completely unnecessary. So imagine that if you have your archive objects that put to the S3 buckets, then it automatically triggers the workflow already. But for the demo purpose, I'm just manually driving that process right now. So let me do it, open. And what you see here is actually that we could generate a UUID for that archive objects that we're uploading to the S3 buckets, as well as generating an MD5 checksum.
Okay, but for the purpose of this demo, you're actually showing, you're clicking on it, but the serverless framework is essentially kicking off automated services using Lambda, correct?
That's correct. It's going to trigger through a S3 event. So any objects that gets uploaded to the S3 buckets, then it will automatically triggers the Lambda function to kick off this workflow.
Okay.
Yeah. So I'm going to start upload. Might take a little.
And I have a lot of questions on MD5, but I'll save that for when we're going through the architecture diagram.
Okay, sounds good. All right. So once upload is completed, then the dashboard should automatically refresh to see that there is a new archive is ingested, and then there are couple states like S3, media info, transcode, and ingest. So let me switch to the architecture view to show you a little bit more of the technical architecture diagram.
Okay, and
so what we're doing, yep, go ahead, Jack.
No, I was just going to ask, so you used media info to do the technical metadata extract?
That's right. So what we do right now is actually the S3 is triggering our state machine, which is the step function, serverless. And then what it does is each of the Lambda, you could consider it as a state. So we have the media info Lambda that is actually extracting the technical metadata from the media file. And then we have another state called create proxy. And what it does is actually it's going to call out media convert to do a proxy, to generate a proxy version. And why is it important is that we find that it helps to simplify your downstream workflow by knowing exactly what file type that your downstream workflow needs to work with. Consider if you have like thousands of archive objects, it could be like a very different file format, like MXF, MOV, ProRes, MPEG-4, or even WMV. So creating a proxy version that actually is going to simplify like all the workflows in your downstream process.
Yeah, so just to go on that, but Media Convert has a rules-based engine, correct? So I could actually create rules in that system that take the media info technical metadata and then create the appropriate proxy based off the source material that I've analyzed.
Yes, you could do that. For instance, you may know that the MXF file could contain not just 2 channels, it could contain like 16 different channels. So you could actually use the technical metadata from the media info to actually create a rule base in the media convert to say, oh, you wanted to extract all of the channels, time mix all of the channel, or you wanted to just extract like channel 1 and 2, which is your primary channel within the MXF format.
So I could separate out the language tracks that are associated with that MXF. Is that correct?
You could. Yes.
Nice.
Okay, so let's go back to the demo, see where we are. All right, so the ingest workflow is already completed. So if we do a plate now, what's going to happen is actually it's the first screen that it shows actually shows like some of the archive information that we extract from the video, like UUIDs, MD5 checksums, and the archive systems, even
Ken,
barcode.
quick question.
Yes.
Where does the UID come from?
The UUID in this case, we are the one that generating it, but then we also actually, if you provided the UUID, you wanted to preserve the UUID from your archive system, we could do that as well.
Oh, thank you.
But essentially what you're doing is you're launching a framework where somebody can either use their existing UUID, you could assign a new UUID against these assets, or put in or at least you're creating a placeholder in this serverless framework where someone could leverage something like the new SMPTE 2112 ITER add ID watermarked identifier or something else that they want to use to uniquely identify their assets.
That's correct.
Gotcha.
Yep. And it also, for the archive information, it also contains a list of the file within the archive objects. So some of the archive objects could contain like multiple files, not just video, could be some thumbnails and audio tracks. So these are the lists that, for this particular demo, we only have a single file. And then going down the list, that's where the technical metadata that's being generated from the media info. And if I scroll over to the next view, we don't have any transcribe surface because transcribe information because we have not run the metadata, same as the recognitions and comprehend. So let me go ahead and create the metadata.
Ken, so let me just ask you, you said that this dashboard is serverless, correct?
That's correct.
So where is this screen coming from, and can you describe the player?
Yes. So what we do is we actually using the S3 as our web server. So all these contents like JavaScripts and all these assets are saved in the S3 buckets. And then the player, let me just play it. So the player is a native HTML5 player. So there's nothing like you don't need a special player in order for it to work. And then we are not hosting any of the web server in the backend because the entire web client dashboard that you're seeing is actually served from the S3 buckets.
Nice. Okay.
Yep. Okay. So now that I think we have generated the metadata, so if we look at the file again, you see that we actually generated a subtitle using the transcribe service through the audio track, and it does auto highlight it just to make sure, just to show the transcription looks like. And then we have also the recognitions metadata in this case. So when we work with the recognition service, there are two types of operations. One is called storage-based operation. The other one is called non-storage-based operation. So why is it important? When you do a celebrity or labels detection, these are considered the non-storage-based API. And what it means is that you call the API, you call recognition API, and then it tap into our database to do the recognition. So there is no storage that is required. And the downside is that if you have a celebrity that is not recognized by our recognition database, then you will not get a match of that particular celebrity. Same thing with the label. If you have labels like human, people, the common labels that is in our database, in our recognition database, then we'll return a match. And if you have something, objects that is not in our database, then we'll not return a match from the recognition. So that brings to the second operation, which is far more interesting, is the storage-based operation, where that you could actually create your own face indexing, create your own collection. And in this particular demo, we actually do that with the collection, naming this particular instructor, David Elliott. And then you will see that there are, it matches his face. And also, if you look at the confidence level in the parentheses, you actually get a much higher confidence level back from the face matching.
So that brings us to a great conversation here. So essentially, we're taking an asset that there was almost no metadata against, other than the technical metadata that was in the file. Correct?
That's correct.
And
So all the
we took that file, and then we've run. So it didn't have a great deal of metadata. We've created an MD5 checksum. We've given it a universal identifier. We've done a technical metadata extract. And now you've run it through these media analysis tools, which have given it a transcript, so speech to text. You've run it through recognition, so I have objects and faces in there. And then there is a third service, comprehend, right?
That's correct. Comprehend is our natural language processing service. And what it does, we actually feed the transcription from our transcribe service into the comprehend service. And what it does is it's actually trying to figure out the sentiments of the sentence that we fit into it. And it will basically generate the key phrases, recognizing persons, locations, and other information. I think I should probably show you one that we pre-populated. It has like 30 minutes clips, and it has more of the comprehend information to show you. Let me look at it.
So essentially, we're taking assets that have literally almost no metadata against them. We're now creating a great deal of metadata against those assets. But I also know that AI services can generate a lot of noise that can be addressed with this confidence level. Have you accounted for that with this?
Yes. So when we run through all these AI ML services, you could actually set the confidence level of like what metadata, like what confidence level that you wanted to filter out. And in this particular case, we set it to 0.5. So anything that less than 50% confidence level, it will not return. Right. So if we look at this particular file, let me see. And what we do is same thing at the recognition. We actually, if you recognize, the guy is actually Will Ferrell, and then the lady is actually Molly Shelley. But instead of using the celebrity's name, I actually created a collection using the character name called and Tish. And you see that, the recognition actually able to do a face matching and return the result with the character's name with a much higher confidence level. Same thing with the comprehend, that what we do is we have like all these key phrases being extracted from the video, from the audio track of the video. And you see that it recognizes like Pasadena, California, flowers, and it recognizes locations, United States, West Coast, East Coast, and it recognizes like quantities and also dates, organization, Amazon, Honda, Prime. All these things that's actually coming from just the audio track.
Right. So comprehend starts to put some context around the metadata that we're capturing, correct?
That's correct.
Okay. So, all right. So from from managing content archives, this feels like a great solution as we've been talking about. But let me ask you this: how are we addressing the serverless with MD5? Because in the M&E industry, they're dealing with very, very large video files. We've even been talking to customers that have video files that are terabytes in size. And I know that Lambda has a time limitation. I think it's around 5 minutes. So with that being the case, how are you addressing doing an MD5 checksum and remaining serverless?
Yes. So we all know that the MD5 is a linear process that require the previous state to do a computation of the next state, right? So the way that we deal with the Lambda function is that we actually break the MD5 function. So we run the MD5 for a range of a byte range. Like for example, like the first 10 gigabyte. Consider if you have a file of 1 terabyte. So we run the first 10 gigabyte file to calculate the MD5 checksum, and then we save off the state of the MD5. So at the end,
you save off the state using what?
Using step functions. So we're running through it with a step function. That step function it does is it runs the Lambda function repeatedly. And the first time that it runs the Lambda function, it runs the first 10 gigabyte MD5 checksum, and then it saves off the state and the bytes that is being processed. And then we go through the step function to basically go through a loop to run the second Lambda function to continue that process with the state that we got from the last Lambda function until we run through the entire 1 terabyte file size. Then we'll have the MD5 checksum and completely running in serverless.
Nice.
Yep.
Okay, so you've shown that we're taking video. We can put video up in the system. So with that, knowing that MD5 can be done for large files, knowing that we can put metadata against these assets, we can extract the audio elements out of video formats. How hard would it be to plug in other services into this framework, Ken? So say I don't want to use Media Convert, maybe I want to use a different ISV partner like Telestream or Brightcove's Encoder or some other service that I may have a contract with.
For this particular demo, we use Media Convert, but then if you look at it, it's just one state within the state machine. Yep. So it's very easy to modify the state to actually just use any other solution instead of Media Convert.
So essentially, think of the serverless ingest as a framework, right? It's, you're setting up the building blocks for an ingest workflow. These are workflows that, are commonly built from scratch and take a long period of time to set up. But with the, this framework essentially lays out the architecture and then people can modify as necessary to match their environment.
That's correct.
Okay. So the end result will be a standardized repository in Amazon storage of master content and proxies and metadata. What about the ability to move the master content into Glacier?
When you ingest the archive to the S3 buckets, so what we do is we actually set up 2 buckets. One bucket, it's actually hosting all your archive objects, and then you will set up a lifecycle policy to move all these archive objects into Glacier. And then the second bucket, what we use is we use it to store the proxy version of it, and also as well as the dashboard player that you're seeing. So those are as far as for the Glacier, then you should set up a live policy to move your archive objects into the Glacier, like within a day or 2, right?
And the proxies, those could be moved into a single zone storage model for a lower cost.
That's correct.
All of the content. Nice.
I also wanted to show you another thing, how we actually use the metadata, and then I will show you the demo of how one of our partner, the MEM system, Levels Beyond, use or consume the metadata in their project.
Okay.
Sounds good?
Yep.
All right. So one of the things is you have all this metadata now, and how are you actually going to use it, right? So the first thing is we actually ingest all this metadata into Elasticsearch search engine. So all of a sudden, you're just providing a video file, right? And then it generates all these metadata and it make it searchable with Elasticsearch. Like for instance, if I search for Pasadena, what's going to happen is the Rose Parade clips that's going to show up. It's just because that Pasadena is actually being extracted, a metadata that's being extracted from Comprehend. Same thing if I do flower. So these 2 clips will show up because both of them contains the metadata. So how the MEM system actually consumes that metadata, and I wanted to show you one of our partner, Levels Beyond, they have a rich engine UI that actually consuming the metadata that we provided. If I do a search for Tish from our Rose Garden, and it will show up all the clips that contains Tish, and if I double click on it, so what's going to happen? It's going to load up the video that rich engine is playing is actually the proxy version that's provided by us. Subtitle is provided by us. Let me just turn this off. And also, if you look at the timeline, each of the clips, it's actually containing the mark-in, mark-out information of the celebrity that we define in the metadata. So they could actually, like all of a sudden, you could actually have a timeline of these metadata as well as AWS metadata being consumed by the MEM system and make it all searchable.
So just to add to what you just said, Ken, essentially what we've done is we've standardized the output from the serverless ingest process so that the metadata is predictable in following a format that media asset management partners or customers could easily attach their media asset management system to import and immediately power a search experience over that content.
Correct.
Excellent.
So with all that metadata, how did you integrate all that with the Reach engine?
Thank you, Dan. I've been waiting for this question. So let me just go through the architecture diagram with you guys again. The integration is very light. And what it means is that we actually uses the SNS servers to do the integration point. If we actually post a SNS message to a SNS topic, and where that the MEM system, in this case is levels beyond, they'll subscribe to the SNS topic to get notified when there is a SNS message in the queue. And what we do is we actually, from the ingest workflow, we have a message dispatcher sending a message to the SNS topic, and the MEM system will actually get notified and knowing there is a new archive objects being ingested. And so they could take that message and then start their workflow independently. At the same time, once we finish the metadata creation, we also have the same message dispatcher sending the message to the SNS topic. So in that case, the rich engines, levels beyond, will actually take that notification and import all these metadata into the rich engine. So imagine, go ahead.
Or it could be used in two ways. You could either batch move all of your content up into the cloud, have all of the metadata and content available for an integration into a MEM partner, or you could interactively be ingesting content into a MEM system.
That's correct. And as long as if you are interested, not just for the MEM partner, consider if you have like video editing software or any other downstream workflow that wanted to get notified, then you subscribe to the SNS topic and you get notified and start off your workflow independently.
The architecture, where the Reach engine would live in this instance was in the cloud. Is that correct? They had it in their AWS instance?
Yes, the Rich engine. So for this particular demo, the Rich engine is run on AWS cloud, but it actually run on a different AWS account. So the good way about this approach is that you could run your ingest workflow or run your serverless archive migration solution on your account. And if your downstream workflow, like your MEM system, are running onto a different AWS account, they could still subscribe to the SNS topic and trigger the workflow independently.
So the beauty of this, as I see it, is running, you're basically separating the conversation from the archive migration and media asset management. Those no longer have to be the same conversation as a project. So as you move the content up into the cloud, you could move it as a single project and then use multiple media asset management providers to interconnect with the JSON output in this content repository, and essentially allow your users to run a proof of concept where they're focused more on the user experience and the media tools and how they want to utilize the content, rather than create this large monolithic transformation project.
Yeah, yep. That's one thing that I really liked about this approach is it's modular.
So Ken, I got another question for you. Can you show us the diagram above this one? And how much of this is available today? I mean, I know that you're leveraging all standard, standard AWS services here. So I know that those are all available. But we're talking about a framework, probably some CloudFormation templates that could be launched. Can you comment on that?
Yes. So we are in the process of open sourcing the entire solution. I cannot commit on the time yet, but our goal is to open source the entire solution to GitHub.
Right, but the media analysis toolkit is available today, correct?
That's correct. So if we look at the diagram here, the media analytics solution with the recognition, transcribe, and comprehend. So that particular solution is already published 4 months ago under the media entertainment, media analytics, and analyze solution that you could actually download and install onto your AWS account and then run through the media analytics, generating all these metadata.
Excellent. Anything else you wanted to show, Ken?
That's all I got.
All right, let me, okay, so thanks for that, Ken and Dan. I certainly appreciate it. So, these are CloudFormation templates that will be launched. There's nothing, like we said, it's not necessarily new technology. It's frameworks that we're trying to help the M&E community, simplify the process of establishing an ingest workflow in the cloud. We are looking at, continuing to expand and consider how these templates can improve, such as formats and content types, other metadata formats. I know that Dan was talking about ways that, we could simplify the format that comes out of this content. And we certainly want to consider that from a media asset management perspective. So if I'm using AI-driven metadata, and I have user entry metadata, how do we categorize those separately so that as you do technology refresh on the AI generated metadata, as training models get, improve, that you don't overwrite the user metadata in the MAM systems. Certainly want to consider technology partners with these templates. There'll be interest in putting in like deduplication services or QC services into this process. Would love to entertain those conversations. Intelligent filter / deletion, things like SageMaker and computer vision. Would love to see how we can improve elements like deleting out any video assets that have too much jitter, or if there's just a lot of black, minimizing the amount of storage required against content that honestly has no value to the customer. And then of course, as we can make this more intelligent, we can make this more efficient. We feel like this will start the conversation with the archive behind the robots. Many major studios and production companies are dealing with a lot of raw materials based off of production shows that they're not sure what the value is. But if we can continue to optimize cost for our customers and the ability to manage content, we believe that that will become a conversation. So if you'd like some more information on the serverless computing applications, the Amazon website is a great place to go. There are a lot of quick start guides there that can get you started. And we want to thank you for your time. So thank you, everybody. I guess we're ready for questions.